So this problem was sent in to me. They were wondering, how do I solve a limiting reagent type problem? And I'm going to explain to you everything you need to know about this. So when we first see two reactants, this is the thing that's going through my brain. If this much sodium and this much water is reacted to completion, right? To completion, what is the theoretical yield of it? Blah, 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 blah. All this other stuff. I know that I already need to do two sets of stoichiometry because it gives me this weird number right here, 92 grams of sodium, and this other weird number, 76 grams of water. So we need to find out how much is too much sodium or how much is too much water. So what I'm going to do here is I'm going to set this up 92 grams of sodium, and we're going to convert that into moles. So there are 22.99 grams of sodium. Let me double check that real quick. Yep, that is correct. That many grams of sodium in 1 mole of sodium. Then we're going to use the molar ratios from right here, right, and right here in order to find out how much hydrogen we're going to get. And I'm just going to leave this at the moles of hydrogen for now. So we get 1 mole of hydrogen for every 2 sodiums, right? So if I have 2 sodiums, I get 1 hydrogen, gaseous hydrogen. Simple enough, right? Now I'm going to set up the second one, and it's going to be the exact same thing, except instead of sodium, we're going to do water. So H2O times this fraction right here, the molar ratio. Just going to add some extra significant figures just for safekeeping. Grams, can't forget the grams. 1 mole of H2O. Right? And we're going to take that. There are 2 moles of H2O that create 1 mole of hydrogen gas. Okay. Now we calculate both of these. Pull my calculator out. 92 divided by 22.99 divided by 2. And I get 2.0009 moles of H2 gas. Now, mind you, significant figures, right? We're going to check that out in a second, and then we'll round later. Do not worry. This is going to be 2.109 moles H2. Okay. Now, like I said, we're going to figure out these significant figures. Remember what I said in the other lesson. We have 3 significant figures right here, 3 significant figures right there. We are basically working with 3 significant figures. So this is going to round to 2, right? And this is going to round to 2.11. So we can see which one ends up being a higher number, right? That's this one. And which ends up being a lesser number, this one right here. So the excess reactant would in fact be the water because it produces more right here. We can tell that this creates 2 moles right here, and we're going to run out of sodium before we run out of water. So our excess reactant will be water. Weird how this question is asked. Um, I I think finding out the excess reactant is a lot quicker than the theoretical yield. So we're kind of jumping from step 1 to 2, and then back to 1 and then 3. So how to find the theoretical yield? What we're going to do is we're going to take this amount right here, right? 2.00 moles of hydrogen gas, right? Because this won't happen. Like as we discussed before, that will not happen. We're going to take these 2 moles of hydrogen gas and we're going to convert it into grams. Simple as that. Now, I believe that's 2.016. Let me look that up. 2.16 grams of H2 gas for 1 mole of hydrogen gas. And for that, we get 4.03. Three significant figures. That would be our theoretical yield. Okay, and now the mass of the unused reactant. This one's kind of a simple one. All we do is find out what we have left over. Right? We're going to convert it to grams with the molar ratio right here. 0.11 times 2.016. Right? Because we're just worried about the decimal places right here. We only have a certainty to here and here. So we're just going to have two significant figures right there. And that's how you solve that problem. Thank you for watching.